technology, and also, of course, an outlook for the next years, not 25. I have structured my presentation as the OSI reference model. I will start with the physical layer and going up to the application layer, and then I also will talk a little bit about that, what is above that. And I compare this normally with human communication. So I will start with a paper, pen, or a laser beam on the physical layer, the character set, and which is implemented then for those which are a little bit older. They know there were sometimes typewriters, and this represents in hardware, so to say, that what is implemented on the CAN controllers and the transceiver chips. And then we have a lot of things which are normally not that much used, and then we have the application layer, which are in human communication like the grammar rules. Unfortunately, you can't communicate just with character sets or definition of character sets and grammar rules. You need also vocabulary and maybe sometimes predefined sentences or phrases like in phrase books for travelers. And all of these I will cover in respect to the CAN technology. Let's start in the very first beginning. Already in 1992, we have had the first interoperability test on a fairground at the Intercama. This was for process industry, and there was 15 of 35 members exhibiting their products on our joint booth. If we would have this today, then there would be 280 companies because we have more than 600 members. So this would be a very big booth on a fairground. What we have done in the beginning was that we used for the very first time that what is today known as the ISO 11898-2 transceiver chips. Because before 1992, everybody has invented their own physical layer based on RS485 with some modifications. The modifications made it impossible that you could connect one device to another device. So this was the first what we have done on this fairground, and I remember quite well that Harald Eisler, in those days with Philips, that he brought by himself the samples from the factory and gave it to the members who participated in this first interoperability test. You see also Vector already with some analyzer. They look today a little bit different. You can see them downstairs. And what we also have agreed on is for the 9-pin D-sub connector, the pin assignment. So, and still today, most of the industries are using this pin assignment, except some. Some still violate that because they have not known that, but it's on the website from CIA since the beginning. In the meantime, the physical layer has been further developed with some variants, and already in 1993 we have had standardized the high-speed CAN transceiver, which we already used in 1992, and then there was the low-speed transceiver developed or specified in ISO 11519-2, but I think this was never be used, not implemented. Then I remember that we have had the single wire CAN, also not a big success story, but still used in some cars. And 10 years after we have had the first standard for the high-speed transceiver, we splitted the document and we used then a separate document for standardizing or for specifying the CAN transceiver with high-speed capability up to 1 megabit. 1 year later, or in the same year, we have had another transceiver specifically designed for truck-trailer applications. And 12 years after we have introduced the low-speed CAN, we came up with a new low-power, low-speed CAN transceiver in 2006. And then in the following years, we developed for the high-speed transceiver some additional specifications for low-power capability and for selective wake-up functionality. Unfortunately, those documents were not in line with the 2003 released high-speed transceiver specification. So there was different terminology used, and when we came up with the KNFD specification, we decided to use to merge all these 3 high-speed documents into one, which was published last year. What I learned from this: separate strictly the medium access unit specifications from device and network design recommendations. Because in the first standard, there was a mixture on anything. There was something requirements for the chip makers, some requirements for the device manufacturers, and other for the system designer. And nobody was respecting this, but because everybody said, this is not for me, this standard. So I prefer to have this strictly separated in different documents. And with KNFD, we are doing so. The second thing what I learned is that we should not specify things in different documents which belong together. Because there are maybe different editors, different engineers making the standard, using different terminology, different wordings. This is not a good idea. For the physical layer, we need also some specifications for the network design, and you see the list is much longer. And every market has to develop it by themselves. Unfortunately, there is some overlapping, and I think this is even accompanied by additional OEM and application-specific requirements. This is a nightmare, and we should overcome this in the next years. But what comes next for the physical layer? We will see some more smart CAN transceivers with additional functions, and we have already seen some of them, for example, for selective wake up, but we will see also those which provide some functionality for security, filtering of KNFD frames, and also what we need maybe is something what I would like to call dynamic ring suppression. And I hope that we will have, maybe in a couple of years, some more specifications for transceivers which can go for higher bitrate than 5 megabit per second. And also, I hope that we can achieve bus line topologies running at higher bit rates than 2 megabit per second. These are the challenges which we have to face, and I think maybe it's not 10 years, it should be then 2 or 3 years that we achieve that. Let's go one step further to the data link layer. This is much more easy. It was very well specified in the beginning. It was standardized already in 1993 with the 11-bit identifiers. 2 years later, we have had the extension with the 29-bit identifier. And as I said already, in the year of 2003, we splitted the documents between data link layer and physical layer, which would make some sense because it's not implemented in the same device. And we detected also that there are a lot of failures in the data link layer description, so that what was on the market is not that what was in the documents. In 2015, we updated this document with the KNFD protocol, and this was a nice thing to do with you. Also here, I learned some lessons. My major lesson is that I'm not more fighting against CAN 2.0 because this was the Bosch name, but we should make reference to the ISO standard because there are some slight differences. There are some additions which some people don't recognize. But on the other hand, I gave up more or less. Still, I will promote that to use the correct reference. But I see still some parties will never use these references. A lesson which I learned not only for the data link layer, but in general, before we adapt things which are submitted, we should check them correctly. Otherwise, we would have some problems if we don't look to that in detail. 4 eyes sees more than 2 eyes is a German saying. And what I also not gave up, but also I know that's not so easy to achieve, is to standardize the host interface because most of the chip manufacturers want to make their customers depending on their products. Fair enough. On the other hand, we have standardized or trying to standardize a minimum functionality so that if you change the microcontroller, that you have still a similar interface. What comes next? In South Korea, some South Korean scientists have proposed in an IEEE paper something which can go up to 100 megabit per second. And they can run, that's what they promised, they can run classical CAN communication simultaneously with no impacts. This is known as TurboCAN, and you can download this paper from the internet and some additional information, and you also some videos where you can see on that it's really working. I don't know if this works in a real environment, but on the laboratory it works. One step ahead in the OSI reference model, most of the network layers are not implemented, but everyone has implemented a transport layer. You see here a selection of them. The first one was the CAN calibration protocol, then we have had some for CAN Open, for DeviceNet, for J9039, and later on also for the automotive industry known as ISO-TP, and we have the extended calibration protocol, etc. What I learned from this, each application domain likes to invent its own transport protocol. This is like reinventing wheels. So at the end, we can say they have not learned their lessons. And what I also learned from the new CAN-FD transport layers, it is better to have a byte-oriented protocol overhead instead of a bit-oriented, because this is something boring to implement that. And you can see, and I think there is a presentation also here in this conference on the USDO protocol, and where we can see these benefits. Migrating to CAN-FD for all of those transport protocols was quite easy to do. And you see here that some of them have already done it, and Mr. Koppe will explain this for CAN Open in more detail, and in this, before the lunch, also Ralf Knüppel will explain how they have adapted CAN FD for ARING for aircraft applications. So the lessons learned, it's quite easy to do so, and this is not a big deal. And if done properly, then you can add also those things and adapt those things from other transportation protocols. This would mean that it would be possible to have one transport protocol at the end for all applications. Because to transport larger data than 64 byte is for everybody the same. So what comes next? Unfortunately, there will be no harmonization. I don't expect this. I hear, no, 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 it should be backwards compatible. On the other hand, it might be that you surprise me and you will be able to harmonize all these protocols. We will see. Next, we have a protocol which doesn't fit 100% into the OSI layer. This is the time-triggered CAN. It is something in between. It's not the data link layer, it's not a session layer, it is something, let's say in these words, but it's below the application layer. To make it short, we specified it in 2004 internationally, and there was also some participants in these groups still here. Lesson, what I learned, we was too late. That was before the TTP and the FlexRay, and the automotive industry has already adopted it. Even if they have not standardized it, and even if they was not ready. But for political reasons, we could not make TTCAN a success story. But there may be that somebody combines CAN-FD and TTCAN and use it. CAN-FD and TTCAN, yeah. It is highly questionable that this will happen. Still the same restrictions and the same limits as with classical CAN and TTCAN, but as I said already, you may surprise me. The layer 7, this is the application layer, and don't mix this up with the application. This is what was in the 90s a big fight between different technologies all over the world. This was the so-called Fieldbus war. You see just the selection of those protocols with or without application layer was fighting to each other on bits and bytes, and it was really awful. CIA tried to stand on side of this battle because we was not fighting, and I'm a peaceful man and I don't like to have war, because if there is war in the world then I lose members. Okay? I don't like to lose them. And this was like in the monument to the Battle of the Nations from the 19th century. It was mainly a fight between Germany and France in all the standardization bodies. And I remember that I was sitting with a German delegation, and then I saw some people from Denmark, and which I knew personally. I was sitting on their side, and then the German delegation leader came to me and said, "Please, would you stay with the German group?" I was a little bit surprised. I was in those days a little bit younger, and I was the youngest. I said, "It's still the Second World War?" And he did not understood. Okay, in those days it was very hard. Everybody was fighting against the others. And even in the CAN community, we have had different application layer protocols developed. CIA started quite early in 1992. In the first year of its establishment, we started to develop the CAN application layer. The CAN application layer was, I think, a very good application layer program, but hard to understand for normal engineers. It was pre-developed by some academics in Germany, and mainly driven also by Philips medical industry, together with the STCP in those days, which is, was represented by Professor Etschberger, and Christian Schlegel maybe has some more on this background in his presentation. It was powerful microcontrollers as 1 year then, or it already started to develop CAN Open in a European research project. This was later on one of the most successful projects in this in this range of ESPRI projects, financed by the European government. In parallel, also DeviceNet was developed, and J9039 by SIE. In the beginning, Rockwell, who was behind DeviceNet, was coming to me and saying, "Okay, could you also promote our DeviceNet?" I said, "Yes, why not? It's CAN-based." But then they said, "But we want to have a special right to vote." I said, "No, in CIA, every company, if big or small, has the same rights." No, we are the big guys. And so they invented their own ODVA association because I was not willing to give them special rights compared to other members. J9039, they was developing something also based on CAN. And this continues, and you see that we have up to the year of 2007, when in Aring they started also to develop their own application layer. What lessons I learned from that? Application layers developed for CAN-based networks provide very similar services, if you just look at it from the service point of view. This means we reinvented the wheel several times. The main differences is the flexibility of the provided services. But if you use the most flexible approach, then you are covering also the more restrictive ones. So hopefully we will have a new application layer developed, not one wheel more. The conformance testing was requested by the automotive industry on the chip level for the data link layer and for the physical layer. And we have standardized this in the range of ISO 16845. In the meantime, we also have some conformance tests for higher layer protocols. The conformance testing is like spell checking. It doesn't guarantee communication interoperability. This was not understood from the automotive industry from the beginning. What they really need is an interoperability test and not a conformance test. And if you have different conformance test plan implementations, even more worth, then this may lead to different results. So what we need is interoperability testing, and we can do so in so-called plugfests. There we can prove that you can communicate one to another. This is like in human communication. If you discuss this with your wife, sometimes there's a misunderstanding. It doesn't matter. This is the thing. Even if you have said something correctly, it doesn't help you. Or we have a golden system. This is the other option to have interoperability tests. And I learned from these discussions in the last years that we need interoperability tests, and this is still always just for one system valid. The system designers, they should be interested in the components and devices tested on interoperability. Component suppliers, in my experience, are very interested in that because they want to avoid as early as possible some misdevelopments. But device makers are normally not that overwhelmed about interoperability testing. So we have also this we offer this for our members, and nobody is interested in that. They test with the customers. And we would need international standardization, interoperability tests standardized. We do this for the automotive Ethernet. They have learned the lesson. Open Alliance has submitted now for the physical layer tests some interoperability tests. What we also can do if we're using the OSI reference model, we can mix the OSI layer. This is the idea. A very good idea. You can do this for the physical layer in CAN. There are different physical layers specified. We can also use this for the data link layer, and we can use higher layer protocols with other data link layers. For example, in the industrial world or in the non-automotive world, CAN Open has been adopted by 4 other Ethernet-based approaches, and unfortunately, they have changed some services, so it's not 100% the interoperability, but it's still quite good. The other way is what the automotive industry is doing. They invent some middleware, hiding the details of the application layer, but this increases the software overhead. You have to pay something for that. And DeviceNet has done the same for ControlNet and Ethernet with their SIP application layer. When you are mixing those things, then you have to specify in detail for each layer what you have implemented. This could be added by some layer setting services and some generic parameters. The lesson I learned is, in order to achieve the communication interoperability of devices, we need to implement in all the same layers, and we have to specify them clearly. And we have a lot of mismatches if you buy products from different parties, if you don't take care of this as a system designer. But this still does not guarantee interoperability on the application level. Still, you may have a sensor measuring something in Reaumur. Who knows Reaumur? Okay, this is something different than Fahrenheit and Celsius. And you expect this is Celsius and Fahrenheit, then you are lost. So we also need some additional things for the functional safety. We need a sublayer, and quite early there was invented some proprietary ones in the late 90s, ESALAN, SafetyNet P, and so on. We developed in the CIA the CAN Open Safety Protocol quite early in the year of 2000. We have submitted this for international standardization as EN 50325-5 and was approved for SIL applications. So what I learned is a simple functional safety protocol is not sufficient. We also need to develop an entire ecosystem. And it took us a long time to establish CAN open safety in real applications, about 15 years. The industry was very conservative. Similar thing is for the cybersecurity. We need some sub-layer for that on top of the, or it's part of the application layer. There are a lot of proprietary solutions available. Most of them come from the IT world and are related to the higher layer protocols. CAN is often blamed to be unsecure, but this is the same if you say a door without a lock is unsafe. Of course, it is. We need it. And so we need to develop a lock for CAN. So what comes next? We have to have a functional safety protocol, not just for one application layer, but for all of them. In particular, in construction machines, we see that we have different CAN higher layer protocols implemented, and then we need from one end to one end, independent of the application layer, functional safety protocol. We need also a common cyber security protocol for authentication on different layers. And we need to combine both of them, and then we have to use CAN-FD with a larger payload, no doubt. This is an invitation to you to do this together with CIA, because this is not existing yet. The device profile specification, briefly, and I'm running out of time, is that we have developed this in CIA as well as ODVA and maybe some others. The lessons, what I learned is that always those specifications are a compromise between those which want to have it very strict, the system designers, because they want to have a high level of interoperability, and those which want to have the major freedom to design scalable products and to extend the functionality manufacturer specifically. Device profiles improve the application interoperability, but still require some device configuration. Application profiles, they describe the entire system. We have developed this for truck applications, for maritime applications, and for agriculture machines. And CIA has also developed this for lift applications, for extruder downstream devices, and so on. We have done a lot of this. The lesson what I learned here is that we can do so, and we don't need then to configure the devices, so to say off-the-shelf plug and play. On the other hand, those devices can't be used in other application fields, so this is then limiting the market. Also, we need some standardized gateways. We have developed this already, and we heritage from some others, some documents where we have to further develop these profiles for interfacing between Ethernet and CAN open. We have developed some others for J9039 to CAN open, and so on. Using the very same application layer and mapping the data link, map to different data link layers would avoid this. Then we don't need those standardized gateways because we have the same access methods. Also, middleware of AUTOSAR encapsulating different communication protocols avoid those definitions for interface profiles. However, here also we have an additional software layer which requiring processing resources and memory resources. In this very moment, the German machine builder industry forces the industry automation suppliers to use OPC UA, which is an Ethernet-based protocol, including standardized device data models. If used in real time, they will go the way of TSN, the time-sensitive network. And this is also a candidate for the automotive industry to achieve real-time capability on Ethernet. So you see that it's growing together. The OPC UA communication networks are like a relay station between the deeply embedded networks and the IoT world. That's what is called cloud and processing big data. So the lesson to be learned is that we have to achieve application interoperability in heterogeneous network systems. Device and application profiles need to be standardized bus independently. We have already in the year of 2004 proposed this to the other industrial consortia. We nicknamed this Pro-Open, but we were 1 decade too early. Now we're discussing it. To summarize, we should not specify requirements to be implemented by different parties, chip makers, device suppliers, system designers in the same document. This confuses, in particular, younger engineers. We should write specification standard as implementation independent as possible. Sometimes we have not. We should try to reuse already standardized protocols and do not reinvent wheels, looking even to other application domains. I know automotive industry is never looking on the right or left side. They just think they are big enough. We should not stop standardization before we have achieved application interoperability in heterogeneous communication network systems. And we should standardize conformance and interoperability tests not only for the lower layers, but for all layers and all profiles. And we should be patient. This is my personal view. Sometimes standardization requires a long breath. And in some cases, we might be too early or too late. So we are not at the end. There are still a lot of things to do. Thank you.
Okay, thank you, Mr. Zeltwanger, for your personal insight. So it's now up to you. Do you have some questions to the presentation of Mr. Zeltwanger? So maybe I start with the first one. So you called your presentation a personal review and an outlook. So maybe let's start with a personal question. So you reminded us that CiA celebrates today, or yesterday, the 25th birthday. You witnessed the entire story of Canon automation from the early beginning. So maybe what was the reason that you as a young man said, well, I spent most parts of my work life for promoting this communication technology?
When I remember correctly, I was right. I was in those days before the establishment of the CiA. I wrote some articles about the CAN bus in the Wien eBus magazine and in some other magazines, and I was a technical editor for different magazines. And I was fascinated from the technology. And then I spoke to some early adapters which I knew from those companies like STCP and others. And I asked them, why is your product not compatible with the product of your competitor? This was on the physical layer, not compatible. And then they said, because we have not spoken about this. I said, why you don't do that? And then they said, I can't go to my competitor and ask him. So I went and organized the first meeting. I think it was in January of 1992, and I invited 8 companies and 23 was coming. And that was the starting point for that. And in the first 2 years, I still worked as a full-time editor in parallel to the organizing or managing the CiA association. And then my wife said, okay, you have 2 choices. One choice is take your job as an editor or run with organize the association. And the third is I will go with the children. And then I decided, okay, this will be a hard time maybe. In the first years, there was not that much income in the CiA. But already after 2 years, I hired the first secretary, and still she is with us, Gisela, and she organized this event here. And yeah, this is was the beginning, and I was never thinking about that if this big future. When I was becoming 50, this was the last time when I thought, is this the right profession for you? Because then I was young enough to decide to do something different. But I thought, okay, CAN is still a good technology and will stay for the next 15 years, and then I will be retired. And now I think next year I will be officially retired, but I still will not go for the lazy days only.
Okay, Thank you very much.